Hello, grade 11s and grade 12s. Let's quickly do this question under Newton's laws. Let's go straight to the statement. Then we are going to analyze the statement, underline the most important keywords there. Then I will write some steps to answer the questions on Newton's laws. First of all, let's go straight to the statement. The statement reads as follows. A box with a mass of 45 kgs is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at constant speed. Now let's go straight to the keywords. Let's go straight to the keywords there. It is very important to underline the keywords. For example, we are given the mass of the box, then we are given the force that is applied, and we are told that the force is applied at an angle. So then they say the angle that is applied is between the force and the horizontal, which means it's a perfect force to use, angle to use. Then they say the box moves at a constant speed. This is very important. F net is equal to 0 because of constant speed. F net is equal to 0 newtons because the acceleration there is equal to 0. There is no change in speed. There is no change in velocity. Therefore, net force is equal to 0 and the acceleration is equal to 0. So the first thing that you need to do when you are about to answer equations with Newton's laws, ufuneka uzobe i-free body diagram. Draw your free body diagram. There is a surface here, which means we have the normal force. Then we have the weight, that is Fg. Then we have force applied, that is 90. We have a force applied. Then we also have a friction, that is Fk, because of this statement define the frictional force, which means there is a friction. The surface there is rough. Okay, so the free body diagram will be like this. The object is a bullet now. So the object here is a bullet. So it's a normal force that is going straight up. Then we have the force that is applied. That is applied force. Then we have Fg. Then we have a force that is parallel. Remember, when you are drawing the free body diagram, when you are about to draw the normal force, you have to define the normal force. The normal force is a force exerted by the surface to the object in contact with it and acts parallel, which means try to draw a force that, or acts perpendicular. Try to draw a force that is perpendicular to the surface. Then the frictional force is parallel to the what? To the surface. Okay. Now the following step, I said the first step you must draw the free body diagram. The second step, if there is a force that is slanted, draw the components. We have components, that is Fy and Fx. Then remove the original force after you have drawn your components. Remove the what? The original force. Then we are left with the components. This is the normal force. This is the normal force. So we are left with the components. Now that is the free body diagram. Another thing that you need to know is that when you calculate the normal force, we say upward forces, the sum of the upward forces is equal to the sum of the downward forces. That is the normal force, which means in this case, our normal force will be will be, our normal force will be the normal force, that is upward force, plus another upward force, which is Fy, which is equal to the downward forces, that is Fg. That is our normal force. We are going to calculate the normal forcing using this formula. Okay, let's go straight to questions. The first question says here, define the term kinetic frictional force. You just define as it is with exam guidelines. So is it definition here is what? The free kinetic frictional force is a force that opposes the motion of an object relative to a surface. That is a frictional force. Then the following question, which is question number 3.2 now. 3.2 says, state Newton's first law of motion. So Newton's first law states that a body will remain in its state of rest or motion at constant velocity unless a non-zero resultant or net force acts on it. That is Newton's first law. Newton's first law uthetha a constant speed or the object that is at rest. Uthetha inertia of an object. All right, let's go to another question. That is question number 3. Question number 3 to calculate. So when we go to a calculate, we always refer to the free body diagram, which means sizojonga about calculator is it a force on vertical forces or is it a force on the horizontal forces? So it will calculate the magnitude of what? Of the horizontal component. The horizontal component is Fx, which means we are going to calculate Fx. So the formula for Fx, I will explain it after this. The formula for Fx is a force that is slanted cos theta. Force that is slanted cos theta. So the force that is slanted there is what is force applied, which is 90. So the force is 90 cos. The angle that we are talking about here is the angle between horizontal and a force. The angle there is 50. So then let's press the calculator. Let's press the calculator. The answer is 557,85. That is Fx. That is this one, Fx. Newtons. That is Fx. Then we get the marks that was allocated there. Then we have 3.4. 3.4 says calculate again, which means even on 3.4 we are going to refer to the free body diagram because the question says calculate. So we are going to refer there to that free body diagram. Calculate. We are going to refer to the free body diagram. Okay. Now let's look at the question. The question itself says calculate the magnitude of the what? Of the normal force. Remember I said upward forces equal the downward forces. That is the normal force. I already written the formula that we have based on this free body diagram. The force, the upward forces, that is normal force plus Fy, is equal to the downward forces, but we have only one, that is Fg. So we need to calculate first the Fy and we calculate Fg. Fy is equal to F sine theta, whereas Fx is cos theta. So the force is 90, sine the angle is 50 degrees. Now let's press the calculator. The answer there is 68,94 newtons. That is Fy. Then let's calculate Fg. So Fg is a weight which is equal to mg. The mass there is 45 times g is always 9.8. Then Fg is equal to, let's press calculator, 45 times 9.8. The answer is 441 newtons. That is Fg. So now that we have the values, let's substitute. Normal force is what we are looking for. Normal force is what we are looking for. Plus Fy is calculated now, Fy weight. So Fy, 9494 in fact, which is equal to Fg. Fg is 441. Then we transpose this one. When we transpose, its sign here change. Therefore, the normal force is equal to, let's press calculator, 441 minus 68,94. So the answer for the normal force will be equal to 372,06 newtons. Then the answer is, the question is answered in fact. Alright, now let's go to another question. Calculate the coefficient of what? Of kinetic friction. Do we have a kinetic friction? No, which means we need to calculate the kinetic friction. Okay, so in this case, the formula that we have to use is number 5, this one. F net is equal to 0 because we said since kuthiwa constant speed, F net is equal to 0. So F net is equal to 0. Okay. What are we looking for? In this question, we are looking for a friction, which means sizojonga i-forces as horizontal. As horizontal yile ne-friction lesiyifunayo. Therefore, let's choose direction. This one must be positive. This one must always be negative. So we have Fx minus Fk to make F net, which is equal to 0. Now we're looking for this one, we're looking for friction. So we can transpose. We have Fk, which is equal to Fx. Then Fx is already calculated there. So that is Fx already calculated there. Then let's bring Fx up ezantsi. So Fx wethu ubani u-57,85. Okay. Oh, this was positive here. When isizawucala ifike kube negative, sibe no negative, then no negative Fk kweli. Then we divide by -1 both sides to get rid of la negative. So Fk is equal to 57,85 newtons. Let's go back to the question. The question says calculate the coefficient of kinetic friction. Now that we have calculated Fk, we can go straight to the formula. The formula says Fk is equal to the coefficient of kinetic friction times the normal force. The normal force is already calculated kule question. So the normal force is calculated already, which means we are going to substitute in place of the normal force. and fk is calculated now here, then we substitute it there. So sifumane ke ngoku u-fk wethu u-5.7,85, which is equal to coefficient. Okay. Let's calculate it here. Let's use this area. All right, which is equal to coefficient of kinetic friction times normal force. Now it's normal force. Here is the normal force. Normal force is 372.06. Then since sifuna i-coefficient, so divide ngo 372.06 nakweli cala 372.06. Then that cancel that. So the coefficient shiyeke yodwa phaa kwelaa cala, coefficient of kinetic friction, which is equal to, let's press calculator here. So we have 57.85 divided by 372.06. Then the answer is 0.16. That is the coefficient of kinetic friction. Okay, then so let's go straight to this question now. Will the coefficient of kinetic friction change if the angle of the applied force is decreased? Now let's say the angle is decreased. What will happen to the coefficient of kinetic friction? Okay, i-object le is a mover in the same surface. I-object is a mover with same material, which means the coefficient of kinetic friction didn't change because kusasetyenziswa the same material. Therefore the answer is no, because kusasetyenziswe the same surface, the same material. So i-answer yethu nguphaa ube no, ngenxa yematerial esiyiswe iseyi-one material ehamba kuyo la object. So the answer there is no. All right, now let's go to, then we're done in answering questions. Let's go to the explanation why fx is equal to f cos and why fy is equal to f sine theta. Let's look at this diagram. In this diagram we have the slanted force, this one. So there is a slanted force there that have components, that is 90. Then if we have components, we have the x component. Let's try to make a triangle. Then we have the y component. This is y, your opposite. This is x, your adjacent side to this angle, which is 50. Therefore, to get this one, while you have this one, which trig ratio are you going to use? This one is adjacent side. This one is hypotenuse side. So we have that thing, SOHCAHTOA. We have what? We're given the hypotenuse. We are looking for what? For the opposite. We use sine. But if we have hypotenuse, we are looking for adjacent. We use cos. So cos theta is equal to adjacent side over hypotenuse side. Then cos theta is equal to, adjacent is fx. Then hypotenuse side is the force that is slanted, that is F. Then we cross multiply, we have 1 time fx is fx, which is equal to f times this one, it's f cos theta. Then we get that one. Then for y, this is y, which is the opposite. So we are going to use sine theta, which is equal to opposite over hypotenuse. So sine theta is there, then opposite to fy. Then hypotenuse force slant layer, then we cross multiply 1 times fy, that is fy, which is equal to f sine theta, because you multiply this by that. So that is fy. Thank you very much. The next video will be on an inclined plane. The object is moving on an inclined plane on the next video.